Welcome to the virtual demonstration of the SITOP PSU8600 power supply system. The demonstration software was programmed in HTML5 and runs on all the usual browsers. This first video will give you an overview of the simulated application. In this application, the SITOP PSU8600 power supply system is completely embedded in totally integrated automation. The PSU8600 can also openly communicate with other automation systems via Industrial Ethernet in OPC UA. However, here we show the integration in TIA, controlled by the SIMATIC S7-1500 PLC with the CPU 1513 and the SM523 digital input-output module. We are using a 15-inch SIMATIC IPC477E for visualization and data processing. The power supply can be very simply configured through the TIA portal and integrated in the Profinet network. We are using the 3-phase PSU8600 basic device with a rated output current of 40 amps. It has 4 10-ampere outputs that are monitored for overload, which makes it a very compact solution with integrated selective protection. The basic device can be expanded to include various modules via this connector, known as the system click link. For instance, it can be used to expand the system to include up to 32 additional outputs, or to transform the power supply into a full-fledged DC UPS. In this application, the only additional module is the BUF 8600 4-seconds 40-amp buffer module. If the power fails, the integrated double-layer capacitors, called ultracaps, provide a load current of up to 40 amps for 4 seconds. Pre-configured WinCC faceplates are used for visualization. The faceplates for the PSU8600 are available at no charge. You can see the status of the basic device and the most important values at a glance on the PSU8600 faceplate. The operating status, the input voltage along with the voltage, and current values for each output. The system load current is the sum of all output currents. Under Information, you can also see the serial number and the firmware status of the SITOP PSU8600. Under Trends, you can see the output current characteristic for each output. We have integrated a static graphic for our demonstration. Of course, in reality, this is dynamic and provides information about the behavior of the connected loads. The other faceplates are used for the subsequent simulation runs. We simulate faults, such as short circuits, and various overload states in the control circuit. We also simulate power failures. We review some of the special functions of the PSU8600. These include the ability to adjust the output voltage, for example, to control a fan. We demonstrate how outputs can be completely switched off, for instance, using Profi Energy, available as part of the Profinet functionality, to save energy in non-operational periods. In the next video sequence, we show the switch-on process, the response of the PSU8600s to faults, and the possibility of identifying pending faults. Keyword: predictive maintenance.